Hello everyone. So today let's solve the problem high load. Yeah, this was asked in the Codeforces Round 4 to 3 for the rated for the Division 2 based on the VK Cup finals. Yeah. So let's see what the question states here. You can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem. Yeah. So let's see what the question states here. So there is a guy named Arkady, right? So he must build a connected network of n nodes actually. Yeah, nothing but a tree with exactly k exit nodes. He has to build a tree of n nodes with exactly k exit nodes. Yeah, so just give me a second here. Let me write it over here. Exactly k exit nodes. Node of degree 1. Exit node in the sense node of degree exactly 1. Yep. So and all other nodes of degree and all other nodes of degree exactly this one actually greater than or equal to 2, not exactly all other nodes greater than or equal to 2 with a degree greater than or equal to 2. We have to use the minimum number of wires. So we have to use the minimum number of wires, right? Minimum number of wires, nothing but n minus 1 here, right? So we must arrange the tree so that the maximum distance, we must arrange tree so that maximum distance actually maximum distance in edges between any two exit nodes between any two exit nodes. So this one two exit nodes is minimized, right? So I'll just write here any two nodes is minimized actually is minimized. So this is fine. So we have to output that minimum possible distance and one valid tree. Remember one thing, we have to output the minimum possible distance here, uh, minimum possible distance along with the this one valid tree, right? Along with one valid tree, right? So this is fine, I believe. Yep. So this is the question. List of n minus one edges, basically. Yeah. Just remember this one. So let's see what the question states here again. Yeah, let me read out the question loud. Just listen to this carefully. There is a guy named RKD. He must build a connected network of n nodes. Yeah, n nodes um, with exactly k exit nodes, nodes of degree 1. Yep, nodes of degree 1. Yep. So and all other nodes of degree greater than or equal to 2 and all other nodes of degree greater than or equal to 2. So using the minimum number of wires, nothing but n minus 1, using the minimum number of wires, nothing but n minus 1, we must arrange the tree so the maximum distance, nothing but in edges between any two exit nodes is minimized. Between any two exit nodes is minimized, right? So we have to output that minimum possible distance and one valid tree. We have to output that this one, what we call that minimum possible distance and one valid tree and one valid tree, right? So nothing but the list of n minus 1 edges, right? So this is fine. So this is the question actually. So see here, the output that we have given, so sorry, this one input output. Let's come to the input output. Yeah. So this is nothing but the n, right? So this is nothing but the n, and this is nothing but the k, right? So this is nothing but the k here. The output that we need to get here is 2 along with a list of n minus 1 edges here, 1, 2 as well as the 2, 3 edges. Yeah, according to the question that they have given. So in simple terms, minimum possible distance is 2 and this one valid tree they have mentioned, one valid tree here is this one edges we have to go display, right? Or output, right? So 1, 2 and 2, 3 are the edges, right? So this is fine. Yep. So let me delete this one. Now let's do one thing. Before hopping into writing the code, let's discuss the approach correctly, followed by the complexities, and then let's write the code. As usual, let's discuss the approach first. And let me tell you one thing, before hopping into the approach part, so we will be going with the approach tree construction basically. This is purely based on tree construction, man. So this question itself is graph with the trees actually. So this is completely based on the tree construction approach actually. Yeah. So let's see the approach step by step. We will be going with the tree construction as I've said. Right. So just give me a second here. 1 second. Did I miss anything? All right. So yeah, let's move on with the further things, man. So this is fine. N we have been given 3 here and M we have been given 2. Let's consider the same example for the approach as well. So the first step here, we have to build a tree, nothing but the graph with N nodes and n minus 1 edges. We have to build a graph or tree with the n nodes and this one and n minus 1 edges. Yeah, so this is fine. The code connects each node I. The code connects each node I basically from 2 to n. We can consider this from 2 to n to node to the node this one max of this one 1 comma I minus k 1 comma I minus k. So this produces a compact tree where at most k nodes end up as leaves, actually nothing but the exit nodes, right? So the formula printed for the answer is basically we'll be going with this particular formula itself. Yeah, just remember this one. Let me write this one clearly. Just see this one. The complete problem is based on this formula itself. So we will be going with basically n minus 2 here by k. We'll be going with n minus 2 by k plus this one. So let me write this one clearly. Plus this one will be n minus 3 n minus 3 by k. Yeah, n minus 3 by k. So here this one, let me include this one as well. N minus 3 by k actually. So this is the formula that we'll be going with plus 2 actually. Yeah, n minus 2 by k plus n minus 3 by k plus 2, right? So this is integer division, right? For n equals 3 comma k equals to 2. So this one will be basically this one will be 0 and this one will be 0 as well. 0 plus 0, we are going with a plus 2 actually. So the output has to be 2 here in this case. Yeah, so here this one, what do we call? Actually, the minimum possible distance that we already got here, nothing but the 2. Yeah, we have got here 2. So this is fine. So now for n equals 3, k equals to 2, the edge generation loop connects 2 to the max of 1 comma 0, nothing but 1 here. So right, see, just listen to this carefully, man. Let's move on with the third point here. So for n equals to 3 and k equals to 2, the edge generation loop connects 2, right? 2. So this one I can just write this one 2 to this one max of 1 comma 0. Max of 1 comma 0. So this one is 1 actually 1. So edge we can consider here. Edge we can consider one edge 1 comma 2. Edge we can consider 1 comma 2, and it also connects 3 2 to max of 1 comma 0, and it also connects 3 to max of 1 comma 1. 3 to max of 1 comma 1, which will be actually 1 itself, basically 1. uh, this one we can consider this one 1 comma 3 edge 1 comma 3. So I'll just go with here edge 1 comma 3 here, right? So this is fine, I believe. The two leaves are node 2 and 3 and the distance is 2 here, right? So the path will be path, I can just write it over here 2 1 as well as the 3, right? Matching the printed minimum 2. Yep, so we can just go with the this one, what do we call, the edge actually 1 comma 2 as well as the 1 comma 3. So this is also one of the answer. 1 comma 2 and 2 comma 3 is also fine accordingly they have given the output, so we can consider accordingly with the definition, accordingly with the approach that we went with, the output will be 1 comma 2 and 1 comma 3 respectively, not 2 comma 3, right? So they have strictly mentioned here, see here, if there are multiple answers, print any, print any of them. Yeah, so this is fine. So we can have the multiple answers for this particular this one question, right? So here accordingly with what we have discussed, edge will be 1 comma 2 and 1 comma 3 respectively, right? So finally let's come to the final part. So nothing but the fourth one here, fourth step, after this one finding the edges along with the minimum distance. So this is the graph construction. Basically each new node attaches to one of the first k earlier centers, right? Or node 1 when the index less, keeping the tree compact and minimizing the leaf to leaf distance. So the output that we got here on the third step, second and third step itself. So here we got 2, nothing but the minimum distance edges, nothing but 1 comma 2 and 1 comma 3, right? So this is fine. So the output that we got here is 1 1 2 and 1 3, which matches the output that they have given for the example one. Actually this one differs actually, but accordingly with what approach we want, this one is also the correct answer, right? So now, as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, man. So what will be the time complexity here? The time complexity would lead to big of n. Yeah, the time complexity would lead to big of n because we read input and produce n minus 1 edge in a single pass, right? So overall time complexity would lead to big of n. So what would be the space complexity here? The space complexity would lead to big of 1 here. Why it is this one space complexity is big of 1? Because we will be going with the extra space, this one, ignoring the output size actually. Only a few variables will be used, right? Edges are printed streaming. So it's not big in memory structure, right? So we can just call this one big of 1 space complexity. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of 1 respectively, right? So now as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the right. So this is fine. Yeah. Now let's do one thing. Yeah, we'll be making use of the fast input and fast output along with the this one utility package as well. So different utilities. So let's make use of the input output package. This one utilities, right? A utility package as well. So I'll just go with import Java. So this one. So this is fine. Let me give here. This is fine. Let me go with like a class. So let me go with main here, right? So let me call this one class name. So you can just give any class name that's related to the that's relevant to the question actually. This is fine. Let me go with main method here. Fine. Let me delete this one. Yeah. Also, let me include here mm, throws input output exception, right? So I'll just involve here. This is fine. So now, within the main method, let me paste this one over here. So this is purely related to the input output part. So buffer data for the fast input, print data for the fast output, string tokenizer as we need to this one. Read the first line actually. This n and k they have given here. N and k they have given here. This is nothing but the n and this is nothing but the k. So we have to pass the integers, right? So we are just passing the integers here. So this is purely related to the input output part. Now next let's move on with the main core logic part. So see here, we have to print the computed or the calculated minimum possible maximum distance, this one between two exit nodes, right? So basically whatever the expression that we write, it uses the integer division, nothing but the floor. It is exactly what the original solution needs here. So as we had discussed in the approach, so we will be going with the n minus 2 by k plus n minus 3 by k plus 2. Yeah, so I'll just go with, we have to print this one, right? So out.println. So this one will be n minus 2, n minus 2 by k, n minus 2 by k. This is fine. Plus this one n minus 3, n minus 3 by k plus 2. Yeah, fine. Now, the next step would be we have to build the tree, nothing but the graph with exactly n minus 1 edges. Yeah. For every node I from 2 to n, we have to connect I with a node max of 1 comma I minus k. Basically, this attaches nodes to one of the first k earlier centers or node 1 if index is small, right? So this produces the this one compact tree with many internal nodes, degree greater than or equal to 2 as mentioned in the question. This is one of the criteria. And about k leaves, right? So let's write the simple for loop and let's finish off this one, this particular solution. So I'll just give here int I equals to 2, I less than or equal to n. So this one will be I plus plus. So within the for loop, let me go with out dot println. So this is fine. We have to go with the maximum of uh, 1 comma I minus k here. So let me append here space between the edges along with the I, right? So this is fine. Yeah. Now we are left with only one step, nothing but we have to flush the output to ensure everything is printed. Yeah, so I'll just go with out.flush, or you can just close the output. You can just make use of out.close. So this is fine. So we are done with the coding part. So this is it for the code man. So this is simple one actually. This is completely based on this particular formula. Yeah. So this is fine. Now let before testing or before checking the code with the different inputs and the output. So let me copy paste the signature starter template. Just give me a second here. So let me paste this one over here. Yep. So let me come here, copy this one. Yeah, we are getting 2, 1, 2, and 1, 3, which is absolutely correct. The same thing we had discussed on the this one approach, right? Instead of 2, 3, we are getting 1, 3 because multiple answers are allowed here. This is fine. Let's copy this one. Let's check what's the output that we get here. So yeah, 3, 1, 2, 1, 3, 1, 4. This one, 1, 4 as well as the 2, 5. Right. So this is also one of the valid answers for this one. Valid answer for this one. 5, 3. Input 5, 3. So let me copy this one entirely. So I'll just come to the submission part. So let me, sorry, what did I choose here? 1 second. Yeah, this is fine. Let me paste the code over here. Mm, copy this one. Let me paste it over. And let me hit the submit button. It's 828D, right? Hey Lord. Mm. So let's wait for some time. Let's wait for some time. Not test one still. Let's wait for some time. So test 18, right? This has to work accordingly with the question that I understood. Let's see. So yeah, you can clearly see here in the verdict it is showing accepted, right? So whatever the code that we have written works absolutely correct for all the test cases. This is based on the complete this formula, and this one we are just making use of it to print the edges, right? One valid tree they have asked us to this one display in the form of output. So this one we are doing with this one. So the minimum distance it is this one calculation part. This is completely purely math. So this is based purely based on the tree construction method. We can just call this one as tree construction approach, right? So this is completely based on this formula along with the one valid tree display, this one output, displaying in the form of output. So this is fine, I believe, man. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.